Here's another example of using the substitution method to do an indefinite integral. And here's our indefinite integral. It's the integral of x times the square root of 1 plus 3x squared dx. Now, remember that our first thing that we need to do is to choose a u substitution. Choose something to equal u. And some of our choices here were to look for a derivative du sitting in our integrand, to choose the complicated bit to be u, whatever's complicating this problem, or to just try something. So let's look at what we've got here. All right, now if you're thinking in terms of derivatives, perhaps, you might notice that we have an x to the second power and an x to the first power. And so that idea of the power lowering by 1, that's something that happens with a derivative. So we might want to choose something involving this 3x squared to be our u. Now, that's not the only thing though, because notice, this is not going to work, by the way. If you just took like that 3x squared to be u, you'd still be trying to integrate 1 plus u ultimately with some other stuff around it. And that doesn't help a whole heck of a lot. Maybe, but not quite as much as we might want. So how about we do this in terms of like the thing that's complicating this is the fact that we have 1 plus 3x squared under that square root. We're going to make that our u here. So let u equal 1 plus 3x squared, and that'll really help to simplify that square root expression. So this is going to be our u. And so we need to look at what to do with everything else. So let's take a derivative, du dx, and that would be 6x to the first, right? So working with the differentials, du would be 6x dx. But notice how we don't exactly have that exact expression sitting around in the integral. We only have, inside our integrand, we have x dx, not 6x dx. We only have x dx. So in order to convert this and really convert what we have, we could take 1/6 of each side of this equation right here. Okay? 1/6 of du is going to equal 1/6 of 6x dx. That would be x dx, which is what we actually have in our integrand. So the x dx together are equal to 1/6 du. Okay, so that's what we're going to put in there. So we're going to convert our integral here, indefinite integral, and we're going to have the square root of just plain old u now. That's pretty nice. Times x dx, which together is 1/6 du. Okay, so now everything is in terms of u, and we have this indefinite integral. Let me rewrite it. 1/6. Let's rewrite that as u to the 1/2 du. And this is something that we can actually work with. All right, remember your properties of integrals. The constant multiple here, we can actually pull outside of our integral symbol. 1/6 integral of u to the 1/2 du. And so we can take our antiderivative here. Okay, antiderivative of u to the 1/2. Increase that power by 1. u to the 3/2, and then you would need 2/3 out front. 2/3 u to the 3/2. And don't forget your plus c because this is an indefinite integral. Okay, now we'll just simplify this a little bit here. Okay, 2 goes in once, 2 goes in 3 times. And so we would end up with 1/9 u to the 3/2 plus c. But don't stop there. Even though it's tempting, we need to get this back in terms of the original variable x. So we go back through our substitution, and in place of u, we're going to put back 1 plus 3x squared. And that looks like this. 1/9 1 plus 3x squared to the 3/2 power plus c. And so there is our result for this indefinite integral. You could write that in some other forms, certainly, okay? But this is the basic form of our answer for this. All right, so there we go.